Hello friends, welcome back to the Dr. Tristos channel. I'm your host, Dr. Tristos. And when we last left off, the demo program that we had written, that we just wrote, was looking pretty good. We'd learned how to use equates and macros and org statements, etc. It's really looking nice. The boss came down. He told us, in the future for your final assembly listings, especially on your finals assembly listings, I need you to put the statement Mac list on. And if we look at this, Mac list is not a machine instruction. It's not a Z80 instruction. This is a declaration to the assembler. We're declaring something. I'm sorry, a directive to the assembler. And I knew something didn't feel right about that. We're directing the assembler to list the macros. I believe otherwise it defaults to off. And what this means is when we invoke a macro like we did here, if listing macros is not on, or if it's off, in other words, if it's off, we will only show this statement that invoked the macro. We will not show each time the contents and how it actually assembled in the macro. We want that in the future, or if we are debugging this code ourselves, that each time we invoke this macro, we want it expanded and printed out how it's assembled. So we're going to put Mac list on. And you can make a note, if you're printing especially if you're using printer paper, or if you just want a more compact output, which most of the time, after you're used to using a macro and you're debugging, you know them by heart, or you're the one that created them, you don't necessarily want to see all of these macros expanded when you're viewing the output code. You just need to know that you used it, what the input-output parameters are. You've used these macros, hundreds of times writing code, and you know exactly how it works and what's going to happen internally. So then your assembly listing of the output starts becoming cleaner, more compact, easier to read, but at the same time, if you're making an output for the future, that's maybe the only output that's listing that's going to survive or be shipped around the world for others to use in troubleshooting their product or something, you want to Mac list on, so we can see each time that a macro is invoked exactly how that is assembled. And what do I mean by how it is assembled? Well, we're going to see in this example, internally we can provide, do I want to use the word variable? No, it's not variable because it'll be fixed each time. We can provide input to the macro when we invoke it that will cause it to assemble differently each time. And so what do I mean by that? Let's look at our code here. The boss was really happy with it, and he said, you know what, we really like this idea of building a screen in memory like we did here and having it terminate with a character like ETX. Tells our program to output from the beginning, from data to data string, until we hit an ETX. We're going to send that out the UART. And man, that makes programming a lot easier. People can come in here and just change this text as long as we follow the rules of an assembler, putting things inside double quotes and doing carriage returns, etc. We could build a whole screen, a half a screen, change things around, whatever we want to do. That's really handy. And you know what? We liked your code so well, we want you to make that a macro so everybody can do it the same way. All of our programmers, everybody's going to do it the same way. And we were talking to a man over at a company called Display Data. Ironically, Display Data Corporation was a real company. And there was a guy there named Dave Schreiner, and he helped develop a macro called pump. And this is what they done. They had a multi-user systems. They built a user screen in memory, and then they invoked a macro called pump that sent that screen to the user's terminal out of a UART. Now, coincidentally, they done all of their applications and operating system work was all done in a microdata assembler. So could you make us a macro just like Dave had over at Display Data Corporation and call it pump? And we'll distribute that to all of the programmers. So I said, sure. I got roped into this one. I looked up here. I already have this one macro to test the readiness of the UART. Let's go ahead and, we'll do them in alphabetical order. So pump will come before test. Let's call this one pump. And then you know what? We got two UARTs, don't we? So let's call it pump 0. And it's a macro. Okay, that works. But now I have to come up with what I'm going to put in that macro. And, wow. So, the boss isn't here at the moment. And so I do what all good programmers do. If I either copy and paste or cut and paste the code from my own code, and if I don't have it, I steal it from another programmer. That's what all good programmers do, right? Especially assembly language programmers. And when you do macros, that's kind of what it becomes when I share those macros with other people, because you do write the code once, and other people then can reuse that code. And not only does it save a lot of development time and typing, but an important thing that I want to share with you about macros is that as you develop a base of macros, you become confident in those macros and you know exactly how they're going to operate. And sometimes my code maybe you could have done something a little slicker this way or that way, another way, but instead I invoke macros that I've used before because it keeps it readable. In other words, if you're doing a function and maybe if you use steps that you've used before, even though it may take a couple of extra steps to do it that way, later it's much clearer what you were trying to do because you see that those steps were used very often. You've used them in other places. On the other hand, if you looked at it and you said, well, I could really write this to be very slick and come up with the answer and maybe use a lot less memory or be faster. And unless you're pressed for memory or speed, you may not want to do that because even though you may engineer some slick alternative, in the future, someone else tries to maintain that or read what you've done, it may not be so simple and end up costing a lot more time. So we've got a macro that's beginning up there. Again, we're going to do what all programmers do. We're going to say, well, if we repeat a lot of code, why don't we just come down here and take this out, right? this is kind of the body of what we were doing anyway. Let's just take that and put it up here inside our macro, and then it may not be perfect, but it will be a good starting point, right? So, and then we know right here that, okay, sorry, let me go back to where I was at. So now we got our pump macro, we've got the code up here, and sometimes I like to put a little marker in here. It just helps me visualize where I piped it in and where the end of that is at, so I make sure I get all my editing done. It says load H&L with the address of the data, right? Well, we said that we could pass parameters to the macro. Parameters is a good word to use for it, or data. So we're going to call that, since we're pumping a screen, let's call this screen, like that. And we're going to put a comma because we're going to have to pass some more data here. So instead of just using this word here, we're going to use the word screen. So now the macro named pump has an input to it called screen. It really doesn't much matter what we call this variable. These are local just to the macro, as long as it's a valid label permitted by the development system. So here we put our scope statement, and that ensures that everything is local to this macro, these labels. Now, load H&L with screen, got that $sign, yeah. So now it looks like whatever variable we pass, or whatever parameter we pass to this macro, it's going to load H&L with the parameter that we pass each time when we invoke it. Okay, well, hey, that sounds pretty good, you know? And then when we get in there, we say, well, this is invoking another macro right here. And the answer is yes. Macros can be embedded. So inside this macro, we can invoke another macro. And, you know, we've used this 1,000 times in our other code. We are already confident about this macro. We know exactly how it works and what will happen. So we can build. Once you start creating your macro library, you will be building knowledge upon knowledge, and, you know, tested solid code that you've debugged upon one building block upon another, building more and more complex macros out of simpler ones, putting them together, similar to how in Unix that you build simple commands and then you link them together by piping and redirecting I/O, and, you know, build one sort program and be able to reuse that by programs directing their output to that sort, and everyone shares you can do that's sort of the same that you're doing with macros here. So I've said that we can reuse it. Hey, this looks good, right? But we come down, we're reading it, we'll be able to do these. We know H&L's already got a pointer in it. Here's our terminating character. We'll call that the terminating character that terminates this loop, because we're going to be in a loop. Now here it says jump relative 0, no more text. Come down here, well, there is nothing under it, right? So I got to fix this. This is going to be where the end of our code is at. So, hey, we learned the equate statement. We'll say equate that label to, and we learned the $sign is the programmer. So right here is what we're saying. So no more text is now equated to here, right here. Okay, so we fall through and we have to end our macro just like we did the others. I can type. Okay, that looks good, right? We run on our terminating character, and when we do, we're going to go to no more text. We've determined that is here, and then guess what? That's the end of the macro. Okay, that all looks really good, right? So, going back up here, we don't take this branch, and we, in other words, we're outputting the character. It was not a end of text. It was not a so we output the character, and then we bump our pointer up to the next character, and we go around again. And remember, these labels are all local and internal to just the macro. We could use them a million times, and by invoking the macro a million times, and they're not going to conflict with each other. Okay, this all looks really good. But the boss says, you know what? He said, we want to be able to tell this macro. Let's make it a little more complicated. We want to be able to tell the macro when to terminate. In other words, it may not always be an ETX, end of text code, which is a 04. Remember, if you remember, we did from up here, I'm sorry, a 03 from our 3 decimal. From our ASCII chart we looked at before, end of text. So there may be times that just when it's a carriage return, or if it runs across a null or some other character control code, we want it to terminate. So you look at it and you say, okay, well, I can have more than one input. We already have a comma here. We would not put a comma if we wasn't going to have a second input here. So let's call it term, and for terminator, it's going to be our terminator character. So down here we'll put, let's take this out, and we're going to put in term. So here, compare, and it has the symbol of term, and term is defined from the input at the macro up here at the top, the macro statement, on the macro statement line. So we'll see how that works here in a second. But we look at this over. It all looks pretty good. I don't see any typographical errors. And we decide that we can now go down here and remove our editing mark that helped us keep track of where we had cut and paste some code in, like a good programmer. So we can take that out now. The macros are separated. Probably take that blank line out. That really looks good. So now let's look what our programs become. Oh, it says no op and then halt, but we're going to say, well, let's do one other thing before we do that. Since we've been changing the name of labels, this is a screen, right? We're outputting, it's a screen, and it's my screen. I come up with, so I'm going to call it my screen. And that looks good. Yeah, call it my screen. And so if it was a bad screen, we'd use our boss's name. But since we like this one, and it's hello world and everything, we'll call it my screen. And we come down here now, and our program is going to look really small. If we're going to use that new macro, we're going to say pump 0. So in other words, pump out to the UART 0. my screen. And now we're going to put in that terminator at etx.ascii. It's pump 0 my screen terminating with etx end of text ASCII and then halt. Wow, that looks like a simple program. Let's put a comment in here. There we go. Pump screen out UART0 and halt. All right, let's run that and see what our output looks like here in the on the right in the UART pane. It built it. Oh wow, it's running. Everything looks really good, right? The boss said, well, you know, you have other control codes, carriage return. We need to test that and make sure other things are working just the same. In other words, that we could terminate on other things instead of an ETX. You hit the first carriage return. I want this program to stop the output. So let's go ahead and try that, and we'll run it. We'll tell it we want it to terminate on carriage return. If we look, it printed the first line, hello world. It hit this carriage return, and this loop inside of our macro terminated. Well, how do we know that's what's happening each time? And that's how it assembled. If I go look at our code, our output code, if you remember, we now have told it to list our macros right here. Mac list on. Right, here's our macro. They're listed here, but notice there's no code on the left because this is just where the macro is being defined. But down here we invoke the macro. We have our list macro on, and remember we have one macro embedded inside of another one. So here's our no op, and then here's the pump statement with my screen and terminating with the carriage return, because that's how we did it on our last assembly. There's our scope statement telling it to keep these labels internal to the macro. One of the first things we did was test the transmitter ready. So there again, a scope statement. Okay? But that's normal because that's how the programs work, because there was a scope statement in each one. So you're seeing it run again. Another macro run being invoked. Here's the input statement. All right, come up here. We have two macros and two separate macros. You're seeing this second one down here invoked in a bit test, a jump relative. Here's the labels that's internal to this. So yeah, it assembled. It assembled just fine, just like we expected it to, as if we would have hand wrote all of this code, but we didn't. We just invoked one pump. And so each time the macro is invoked, it inserts this code in the assembly, or expands this code in the assembly. So does that mean you can use it more than one time, right? Yeah, of course. So let's do that. We got our program here, and the first one's going to say hello world, and it's going to terminate on the first carriage return. But let's say we want to do this again and pump out UART0. We're going to invoke the same macro again, my screen. And this one we're going to go on into text. like we had before. Okay, so what's this going to do? Well, I suspect you're going to see it print twice. First time it's going to terminate on the first carriage return. The second time it's going to print the entire buffer to the end of text. Let's run it. We're using the same macro 2 times. I've made a mistake somewhere. Okay, so I made a mistake here, and I had paused the recording to decide what to do. I told you the wrong thing. I told you that this, so I decided whether to remake this and I think, well, I told you the wrong information in a previous video, so perhaps I should just leave it. That will show you that I am by far an imperfect programmer. And I knew this, something didn't feel right, but I just kept going with the wrong info. We're good at that as humans sometimes. Doing the wrong thing and sticking with it. I told you that the scope statement would keep these labels internally inside of a macro, that it would keep them separate and from outside of the macro. And that's not true. If you use a label inside the macro, in other words, if I call this ABC, put that label on here, and I invoke this macro, that label ABC will be universal in my program. You wouldn't want to do this because you could only invoke the macro one time. Now, there's macros that you do invoke only one time in a program. They can be where you are setting up data or something and you only use it one time. You've developed a macro that lets you open up your program. In other words, give it the beginning address and all that, and you pass that in, and it creates a header. You only use a header one time. So, but most macros you're going to invoke more than once. So we want to be able to keep these labels here internal to the macro only. We put a $sign and we number them. If you're writing a macro, it's probably going to have a small number of labels on the inside, so it's just in numbers. It's pretty easy to keep track of. $1, $2. So I've already corrected these 2 macros. One macro, the pump, has 2 labels inside, and the test transmitter ready has 1 label inside. So as you can see, I have corrected them here. And our jump relative goes to the $1. These are internal. As you can see, I have reused the same label in 2 different macros. Now, when we use the same macro 2 times, now I'm telling you the right information. Now, when we invoke it twice and assemble, it will always work. And if we go to our assembly listing of the macro, now the assembler output, we can see these labels and then where we use them. And I'm not 100% sure what it's telling us here. We would have to figure this out. Looks like it's adding a 1, 2 in front of it. It may be the first occurrence of using that label, the second occurrence of using that label, the first occurrence of using a 2, the third occurrence of using a 1, the fourth occurrence of using the label 1. So that's how the third occurrence of using the label 2. So the assembler is doing that so it keeps them unique. Each one of them now is a unique number, 11, 21, etc. And that's how it's keeping, when it does the assembly, that it knows it's not confusing the labels in one macro that it expanded with the labels in another. But you can, your output code looks a little more complicated, and in some ways it is, because you've done a lot here. And these two statements, pump, you've done everything. You're testing the transmitter, you're outputting, you're testing for a terminating character, and you're terminating, all being done in each time in two statements. But it's very clean. Now look, at the beginning of my app, I have a no-op in there in case I want to do a patch, and look, it says pump. I understand I've used pump macro 1,000 times. We know that the first input is where to start the pump from, the beginning address to start from, and then the terminating character, a carriage return on that first time. So did we look at that output? I don't think we did we? When we look at the output of it running, of the UART, well, notice it did exactly what it did. It printed hello world, it hit the carriage return. If you remember, we don't print the terminating character. We simply terminate. So it was still on the same line because it didn't print it. The next time that we invoked the macro, it picked up right where it left off. The next time it printed a carriage return because our terminating character came after this word demo. It has the ETX. And there again, it did not send the ETX. When it received that, it stopped. So sorry about the wrong information about the labels. Are only internal to the macro, and that's true, but only if you precede them with a $. I think you could also, you don't have to use numbers. I think I may give you the wrong information there. We'll try it in a different demo. I think we just needed to precede the label with a $, so I can still call this my loop, because remember, we'll have one my loop. When it assembles, it'll change that to one my loop. The next time it'll be two my loop, three my loop each time we invoke the macro. So yeah, there again, sorry I gave you the wrong information, but you got to see debugging live. Almost live. I paused you. I didn't want you to see me. I had to figure it out a little bit. I've worked with a lot of assemblers, and each one is different. I have worked with assemblers that each one, the label was internal to the macro only. You didn't have to put the $sign in front of it. So there we have it, another exciting demo session of the demo program. Hope we've learned a couple of things. I'd like to keep these videos to about 30 minutes, so we'll leave this here, and maybe you can let that soak in, and maybe I need to rehearse my lessons a little bit, but to be honest with you, I don't really have the time for it. The reason I'm making the videos is because it saves me. I'm not really able to type that much because of some health problems, and it also helps me to just be able to orally tell you guys what I'm trying to convey. And okay, and we have the dog with us again today. She's out, she's happy, CC. So nice weather here. All right, friends, hope to see you back here again soon on the Tristos channel. Thanks.